So we're going to look at how to solve linear systems using substitution. This is another technique, again algebraic, in order to solve to a system of linear equations. So the first step is to select one of the two equations to isolate for one of the variables. You can isolate for x or you can isolate for y, whatever is easiest for you to isolate for. Then you're going to substitute this equation that you've now isolated into the other equation. So it is quite important that you label which equation you're going to work with, so number them 1 and 2. Then you solve for the variable once you've substituted it in, and then you take your solution and plug it into either of the equations to get the second variable solution. Then you have a coordinate pair. So let's take a look at this example here. Let's label this equation number 1 and equation number 2. If I look at equation 1, we're going to do step 1 with it. We're going to select one of the two variables to isolate for. So we can either isolate for x or we can isolate for y. It's your choice. It doesn't really matter which one. Now let's just say we isolate for y. So 2y is going to equal negative 3x minus 2. If I divide both sides by 2, we get this. Now that we have this is our first equation. We take our isolated format of the first equation, and we're going to plug it into the other equation, so equation number 2. Wherever we see a y, we're going to replace it now as negative 3 over 2x minus 1. So, step 2, we take 3x minus 4y equals to negative 32. Wherever we see a y, we're going to replace it with this entire equation. So we will have 3x minus 4, and we're going to plug in negative 3 over 2x minus 1 equals to negative 32. Now I've just simplified 2 over 2 in this case. Now if you notice, now my equation is all in terms of one variable, and I can combine like terms, and I can simplify. So if I go through this step by step, 3x minus, and we're going to multiply and distribute. So when we multiply and distribute, you're going to get a negative and negative makes it a positive 12 over 2x, which we can reduce down in a second. Negative times a negative is positive 4 equals to negative 32. So 3x plus, this becomes just 6x plus 4. So again, because you have two negatives and negatives, both of these are positive. We now have like terms, 9x. So 9x plus 4 equals to negative 32. 9x will be minus 4 on both sides equals negative 36. And if we divide by 9 on both sides, x is equal to negative 4. So there is one of our solutions. Now we can use this and plug it into either of our equations and figure out what y is. So let's take 3x plus 2y equals to negative 2. Again, wherever you see an x, we're going to replace it with negative 4. So 3 times negative 4 plus 2y is going to equal to negative 2. Negative 12 plus 2y is going to equal to negative 2. Add 12. Add 12. 2y is going to equal to 10. Divide by 2. Divide by 2. Y is equal to 5. Now I have these two pieces. We can find our solution, which is going to be negative 4, 5. And again, if you plug it in and test it, you'll know if it's the right point or not. So here's another example. And again, you'll want to label your two equations in this case, and make sure you're working with the right equation as you go through. If we look at the first one, this one's already got a y all by itself. So this one might be actually an easy one to isolate for. A little less work in terms of your algebraic manipulations. So let's isolate for y by subtracting 2x on both sides. So then y is going to equal negative 2x minus 3. So that's my first step. Then I'm going to take y equals to negative 2x minus 3 and plug it in wherever I see a y in the second equation. So 3x plus 2, and we're going to plug in negative 2x minus 3. We can then distribute 3x minus 4x minus 6 equals to negative 4. Combine your like terms, get negative x, and if I add 6 to both sides, equals to 2. So then if I divide by negative 1, divide by negative 1, x then equals to negative 2. One part of my solution is done. Then I can plug it into either of these two equations, replace x with negative 2. So if I use 2x plus y equals to negative 3, and wherever I see an x, I'm going to replace it with negative 2, you'll get 2 times negative 2 plus y equals to negative 3. That makes negative 4 plus y is equal to negative 3. Add 4 to both sides, then y is going to equal to positive 1. Again, we want to write this as a coordinate pair. So, negative 2, comma 1 is our solution for the system of equations.